All right, friends, so this is the second part of 5.6, and there are really, I would say, two concepts here that we really need to hit on. So yesterday, or you've already learned about inverses. So number one, I want to show how you can prove that two things are inverses. So this is how to prove, okay? So I have f of x is 2x minus 9, and g of x is going to be x over 2 plus 9. Now, the way that we're going to prove this is not, hey, I'm just going to find the inverse of it, and if it's the same as this, that's good. That's not how we prove. And the reason I'm showing you this is because it kind of comes full circle back to the whole idea from your ed puzzle of actually having this line. Okay, so the first thing you're going to do, and it's very similar to what we did in 5.5, except this is now looking at doing this. So this really says f of g of x. So see how g of x is embedded into the f of x? Okay, that's exactly what you're going to do. You're going to take g of x and you're going to plug it in to the x on the f of x. So let me show you by taking the pieces. So I'm going to say f of x is yellow here. Okay, and now I'm going to plug in. Sure, now I can't find any of my highlighters. Here we go. Now I'm going to plug in this piece. Okay. All right. You see that all right? So I'm plugging one into the other. Okay. And go ahead and distribute like you normally would. What is, so I'm going to highlight this in there. Okay. What is 2 times x over 2? Well, that's just x. And what is 2 times 9? Well, that's 18. Minus 9. F of g of x is equal to, 18 and 9 is x plus 9. Okay, now you might say, well, geez, that looks okay, but that's not. This is a no, because my goal is I want it to look like this. Now, what's that line? That's my line that I've been drawing, friends. That is this piece right here, the orange line, okay, that I'm an inverse about. So that proves that, nope, those are not. I don't even have to go any further, okay? Normally what you would do is you would take G and plug it into F, and then you take F and plug it in to G, and hopefully get the same thing. Well, let's try it just to show that, you know what, this isn't going to fly. So notice what you're doing now. You're taking f of x and plugging it into the g of x, okay? So f of x into the g of x, okay? So I'm going to take, instead of writing an x, I plug in my f of x into the x part on my g of x, okay? And what do I get here? What's 2 divided by 2? Well, that's x. And what's 9 divided by 2? Well, that's 9 halves. Ugh, yuck. Well, that doesn't work. So what 9/2 is what? 4.5? 4.25? Better check. I'm a little rusty this morning. Four and a half. Goodness gracious, that's it. Plus 9, so x plus 4.5. Yikes, that does not give me what I want. So that is a no. Okay, so that's how to prove whether something is an inverse function or not. Okay, so plugging, our big piece is here, plugging it in 2 different ways. Again, I didn't even have to technically do this second part because I had already proved it on the first one. And that's okay. So if you want to keep that in mind, like once you prove it once, you don't have to prove it again. Okay? So plug them in to one another. Okay, the other piece to the notes is looking at is this graph the inverse or not? So if you remember something called the vertical line test. So remember that we had the vertical line test. Okay, so let me draw. And we graphed lines, or we had a, well, let me do this. Okay, is this a function? Okay, so my second part is it a function. Now remember, a function has one input to one output, but we also did something called the vertical line test. So is this a function? Why, yes, it is. This is totally a function. Okay, so vertical line test for graph. Okay, you can do that when you have a graph in front of you, but what do you do to predict, okay, predict the inverse? Okay, so will the inverse be a function? Well, how do you do that? Your prediction tool is the horizontal line test. Okay, again, same thing as the vertical, but if it passes through only one point at a time, remember this is going to continue to climb, then your inverse will be a function. It is a prediction. Okay, so you don't have to graph it, you can just predict using the horizontal line test. Now, the key word is predict, which means not to graph. If you graph the inverse, then you just use the vertical line test when you're given a graph, okay? So let me do a problem with you right here, okay? So if I have f of x is x cubed minus 1, okay? And the first thing I want to do is I want to predict whether or not the inverse of this is going to be a function. So here's what I'm going to do. I'm going to take my handy dandy calculator and I'm going to put it in on the y equals. Okay. So I'm going to come up to the, goodness gracious, I hit clear there. Go up to the top. I'm going to put in x to the third minus 1, and I'm going to hit graph. Okay, so let me ask you this. Is this a function? Yes. Okay. Yes, this is a function. Now, let me ask you this. Will the inverse be a function? So in order to predict I'm going to use the horizontal line test. So I'm going to take my pencil and I'm going to go like this. And you know what? It does. So you know what? The inverse is a function. Okay, the inverse is a function. And then the rest of the directions say, okay, well then go ahead and let's figure out what the inverse of that is. So let's do that just for practice. Okay, step number 1. So we're going to find the inverse. So the first thing we're going to do is switch around x and y. Well, the y is the f of x part. So x equals y cubed minus 1. All right, let's solve for y. So I'm going to add 1 to each side. So x plus 1 equals y cubed. What's the opposite of taking something to the third power? You're right. We're going to cube it. So cube it. So cube root of x plus 1 is equal to y. And if you really wanted, you could go back and graph it, check it with the vertical line test when you have it in front of you. Other than that, you're all set. Thanks.